So because I don't have time to do the tricks, I recorded them. So this is the first trick. This is all done by a spectator. I give him a deck, and he cuts the deck. He cuts as much as he likes. Now he cuts in the middle. I can. Take the top card and put in the other half and shuffle them. And if he doesn't know how to make a riffle shuffle, how to do a riffle shuffle, he can do this Rosetta shuffle, which is exactly the same. Now the magician takes the cards. He shows the cards to the spectator. He looks to his eyes, on his eyes, at his eyes, I don't know. And when he feels he has to stop, he stops. And it is exactly the card that he chose before. What a trick, eh? OK, so that's the thing. So this is called EM Premo. The EM is a mystery till 10 seconds later. So it's based on an idea that Charles O. Williams introduced to magicians, which is that riffle shuffles leave trace. In fact, if you riffle shuffle a deck, there will be two chains, interlocking chains. And Charles Jordan exploited this idea with many, many, many ingenious tricks. And Jack Macmillan was obsessed with Jordan ideas. And oh, no mystery anymore. EM stands for Edge Mark Premo, because the deck I had there, even if when it's square, looks like normal. When you bevel it, you can see that every card has a mark forming a line. This is the idea of devious idea of Macmillan. And well, what does a cat does today? It does nothing. No, all the three linear orders there correspond to the same circular order. It's like a collar, and you open it wherever you want, and will be the same. And in the deck, you just see the line that is broken, but it's only one line. When you shuffle, what happens? Well, a riffle shuffle will only interlock these two chains, so now I will have two lines. Maybe they are broken if I cut, but there will be just two lines, okay? And with more shuffles, there will be four or whatever. And if you move one card before the shuffle, what the magician sees is two perfect lines and one card which is alone, so you stop when you arrive to that card, and that's the thing, okay? Now we will see what happened with very regular shuffles. So we have here 32 and 31 cards. One is even, one is odd, okay? And 5 riffle shuffles, 5 out faro shuffles in the first case, which means you cut exactly in the middle, and you leave the cards in the border in their positions. They will go to the original order. And with the 31 cards, you cannot cut in the middle, so you cut a big pile and a small one, and you put the small one into the big one, okay? So after 5 faro shuffles, in each of the cases, the order is the same it was at the beginning, both cases, okay? Happy and happy, okay. So what's special about faro shuffle? Well, the only special thing is I can repeat it as many times as I want, because in fact, any shuffle in any packet will go to the original order, and because there must be a proof in every show or talk, as you know, then I will tell you 2 facts to prove it. The first one is very easy to understand. The number of orders that a pack of n cards can have is finite. In fact, it's n factorial. And by the way, this was used apparently in World War I to send messages written in the border of cards. Then they shuffle like crazy. And the other guy knew the order, and they put all the lines to the same side. And I don't know if it's true, but Hahnemann said so. And the other thing is, if you know how to do a shuffle, you know how to undo it. You can record it and go backwards, no? And I thought about a joke, which is GIF turns into fig, but I don't know if it's a joke, really. OK. Now, for the proof. So you take your deck is in order A, you make your shuffle S, you go to order B, and then you will go to C, D, and eventually one order will repeat, okay? But what if it's not order A? Well, you know how to undo your shuffle. So before D, it must come C, before C, it must come B. Oh, so the first order repeat, I told you. Okay, now let's see what happened when we cut the cards in the middle. So I draw one card, there is 31 on the right, 32 on the left, and I cut between the faros, because apparently cats didn't do anything, no? Why not? So I'm cutting, and on the right side, I don't care what is the big pile. I just put the small into the big, into the large. I don't care if it's the top one or the bottom one. In the other side, I only doing out faros again, out perfect shuffles, okay? So now let's see what happens. And what happens is, for 31 cards, I just cut, and I have the same order, and for 32, I have rubbish, okay? Not very happy this time. Okay, So the perfect shuffles, even if for our intuition is, well, I have an even pack, it's more perfect if I cut just in the middle and I do the shuffle. This is very bad shuffle. It doesn't work with cuts, okay? So the good thing is to have an oath packet to cut one with one more card and to put the small into the large, okay? So imagine we have 11 cards, numbers 0 to 10. Then the shuffle will be like this. So every card will be spaced 2, 0, jumps 1, jumps 2, jumps 3, jumps 4, jumps 5. And when you arrive here, you can put 6, 7, 8, and everyone, no? But if you start with an even deck, you cannot do that, and it's obvious because when you arrive to the 5, you want to put the 6 where the 0 was. That's why in an even pack, the faro shuffles cannot work well cyclically with cuts, okay? And in fact, Golom, that you were talking yesterday about him, proved in 1961 that in an even pack of cards, if you use out faro and cast, you can go to any of the n factorial orders. And his proof is very elegant. He only proved that you can change the first and the second card, and the rest stays the same. And with this, you have enough, because then you can and put any order that you want. Okay? Well, if there is a shuffle that works well in the circle, and we separate 2 cards, the cards that were together, don't we separate 3 cards, the cards that were together? So for example, I take this pile, and I put 0, jump, jump 1, jump, jump 2, jump, jump 3, jump, jump 4, and this works, okay? Why does it work? Because this number of cards is 11. What will happen if we have 12 cards? Oh, because 12 and 3 have a common divisor, this will not work, because my red light is there. The only thing I want to say more is, well, what about doing these shuffles is very difficult, but what about undoing them? You just have to deal in 3 piles, or in 4 piles, or in 5 piles. So 13 is a good number because it's prime. Every faro will work. And I leave you with the trick of my friend Germán Bernardo. He think about putting sentences with cards, and it's 40 seconds. So you put some syllables, you cut, and the people will tell you how many piles they want you to deal in, and you take the cards in the order that you need to, okay? And once they say to stop, you just display the cards the last time, and in this display, you are able to put the configuration that you wanted from the beginning, okay? So they tell you to stop now. I say this, okay? Now you put the cards, and for example, you can make something like this trick, which is the cards are forming a nonsensical sentence, which is a nice sentence. Okay. So that was it. Thank you very much.